Jai Hind to all. Today we will discuss about the derivation tree. So basically, derivation tree is a pictorial representation of the derivation process, right? So whenever we will think about the derivations, we will want to generate a string of terminals from the starting symbols. Then we will put it down the right hand side of the various productions corresponding to the non-terminal of that occur during the sentential form. So the entire process is called the derivation process. So the derivation process, when shown pictorially in form of the tree representation, right, then it is called the derivation tree. So in nutshell, we can say the derivation process can be shown pictorially as a tree to illustrate how a word is derived from a context-free grammar. So this tree is called the derivation tree. In nutshell, some authors use the term syntax tree or parse tree for that. So basically, the advantage of these trees are they can clearly show the symbol of terminal strings are grouped into the substrings, each of which belongs to the language of one of the variables of the grammars, right? So this is a phenomena for constructing a parse tree corresponding to a grammar G equals to B, T, P, S, right? So root is the starting symbol always. So root is the starting symbol, right? After that, each node is labeled by either variables or terminals or epsilon. Here stands for epsilon, right? Each interior node is marked by a variable, right? If an interior node is labeled with A, you can see its children is labeled by x1, x2 and so so on xn, then there is a production corresponding to A tends to x1, x2 and so on xn in a grammar. So A is replaced by the x1, x2 right hand side of the production. So children always form the right hand side of the production and the parents always form the left hand side of a production, right? For example, consider this particular grammar. Here grammar is given by the productions, this one, right? S tends to AAA oblique AA, A tends to AA oblique AA oblique AB oblique A and B, right? Here A and B are the terminals. Inside this grammar, there is two non-terminals S and A. Suppose we want to derive a string B A B A, right? I will start from the starting symbol. S tends to, right? Derivation will start from the starting symbol. S tends to, I will take A, right? After that, either you can say leftmost derivation I will prefer here. This A get replaced by what value? You can, if you want, you can replace it by AA, right? Because A tends to AA will be the production. So AA, after that AA will be these parts came from these particular parts. After that, you will preferring the leftmost. So this is the leftmost non-terminal. You will replace it by B, right? What happens? The remaining parts will be appended with this one. After that, next non-terminal from the left hand side will be A. So what happens? You will replace this A by suppose I will require a particular string A. So you will choose the production corresponding to that. So I will replace it by the AA. So B A. Next non-terminals is A. So what you have to do? You will replace it by the another A will be required. So AA. So B A. After that A tends to A. I will use here, and remaining is AA. What will be required at last? BA. So this A is replaced by B. The next non-terminal from the leftmost side will be this one. So you will choose BAA. After that, you will replace it by B, and remaining is A, right? Next non-terminal from the left hand side you will scan. So it is A. So what for what? Remaining part is A. So you will replace it by A times to A. So you will get B, A, B. After that, this A. So this is a leftmost derivation. You can see. If you will represent it in a pictorial form, tree-like structures, then it is called construct a derivation tree or parse tree. So you will start from S. Root node is always the starting symbol of the grammar. What you have to do? You will replace this S by, you have to replace it S by what? A, and A, right? 3A, right? So replacement, in case of the derivation, you can see this replacement, entire replacement, right? Once again, what you have to do? This A is get replaced by what? You can see this A get replaced by B. So you can write down B. Once again, this A get replaced by what value? AA. So you can write down A and A. Once again, this A get replaced by what value? This A is get replaced by A. You can see. Now you can see this particular A get replaced by, you can see, no, I will once again, this is not correct. Basically, I will start from here. S tends to A, right? And you can see this particular A get replaced by AA. So you can write down A and A, right? Once again, you can see this A get replaced by B. So this A get replaced by B. Once again, you can see this A get replaced by AA. So you can write down A, capital A. After that, you can see this A get replaced by A. So you can replace it by A. Once again, you can see this A is replaced by B and this A is replaced by A. So this is the derivation tree corresponding to this particular grammar, right? So what you can think of, basically you can see from this particular derivation tree, if pictorially it is represented here, the yield points means the leaf nodes, when you can concatenate it, form the string of terminals. That is called the yield, Y-I-E-L-D, yield of a derivation tree. Yield of a derivation tree is always a string of terminals. Or you can say yield will be equivalent to the strings that belongs to the language corresponding to the particular grammar, right? So when we concatenate all the leaves of any parse tree, from the left we get a string which is known as the yield of the tree. The yield is a string that always derived from the root variables. So the so you can say this always belongs to the language, right? So there is a parse tree whose yield are in the language of the underlying grammars, right? The importance of the tree is the yield is a terminal strings. All the leaves are labeled with the terminals or epsilon, right? If epsilon will be occurred at the yield points, right? Or at the leaf, so you can append it. So there is no importance. Suppose I have getting this string, let's see, A epsilon B. So whenever you will find out the yield point, this will be equivalent to AB because it is a null string. There is no importance. Either you can write down A epsilon B or you can write down AB. There is no. Okay, you can see here at any intermediate steps, if we will concatenate the elements of a parse tree, you can see here, if we will concatenate the parse tree, means elements of a parse tree at intermediate step, we will get a string like A, B, A. So this is a sentential form. So internal nodes, yield point will always gives you the sentential form. Now we will move towards the equivalence of a parse tree and the derivations. So a terminal string in inside the language of a grammar, if it is in the yield of the at least one parse tree, right? So if you will think about that, if a particular language of a grammar will be considered, so every string have a unique parse tree, or each parse or a parse tree corresponding to that, right? So if any terminal string inside the language of a grammar, if it is the yield of at least one parse tree, there must be existence of a one parse tree, right? So the existence of the leftmost derivation, rightmost derivation and parse tree are the equivalent. So in the particular sense that each defines exactly the strings in the language of a grammars, right? So this shows you the parse tree and derivations equivalence. If you will think any string, there must be a parse tree, right? There must be a parse tree corresponding to that particular string of terminals. The parse tree may be a single or maybe a more, right? But there is a possibility, existence of a parse tree will be there, right? After that, parse tree, derivation tree, leftmost derivation tree and rightmost derivation tree are the synonyms. It is a graphical representation. So you can simply say that derivation and parse tree are the equivalents, right? In some strings of the CFG, it may be possible that any particular string have a more than one parse tree, right? If you will think there is a necessity at least one parse tree. If more than one parse tree will be possible for a particular string in a language of a context-free grammar, then it is called the ambiguous. So now we will move towards the ambiguous grammar, right? Basically, a context-free grammar is ambiguous if there exists more than one parse tree. Or equivalently, you can say if there exists more than one leftmost derivation, more than one rightmost derivation, or you can say more than one leftmost parse tree or rightmost parse tree. So if a particular string have a more than one parse tree, because you can say leftmost and rightmost parse tree. If you will think about the leftmost and rightmost parse tree, both are graphically equivalent, right? You can see, if suppose a grammar is given to you, E tends to E plus E oblique E multiply E oblique ID. I want to generate the parse tree for ID plus ID multiply by ID, right? By the help of a leftmost derivation, by the help of a rightmost derivation. So you can see, if we will apply the leftmost derivation, the derivation will be E tends to E plus E. After that, you will replace this E by ID plus you can see here this one. After that, this E is replaced by E multiply E. It is ID plus E multiply E. Now extremely left symbol is this one, so you can replace it by the ID plus ID multiply E, and at last this E will be encountered, right? So you can see ID plus ID multiplied by ID, right? So this is a you can see derivation, leftmost derivation. If you will think about the rightmost derivation, what you have to do? You will replace E derives E plus E. The rightmost symbol is this one. Now you will replace it by the E plus E multiply E. This is replaced, this E is get replaced by E multiply E, because there is a production here corresponding to that. After that, you will replace it by the E plus E multiplied by ID. After that, you will write down E plus ID multiply ID, and at last you will replace it ID plus ID multiplied by ID. You can see, if you will think of the derivations, you can see here E derives E plus E. If you will think about the leftmost, this E is get replaced by the ID. After that, this E get expanded by the E multiply by E. After that, this E get replaced by the ID, and after that, this E get replaced by the ID. If you will think about the rightmost derivation, you will replace this by the E plus E After that, this E get replaced by the E multiply E. After that, this E get replaced by the, sorry, this E get replaced by the ID. After that, this E get replaced by the ID, and after that, this E get replaced by the ID. You can see here, from here, both the parse tree, leftmost derivation parse tree or rightmost derivation parse tree are same. So you cannot differentiate after looking at the particular derivation tree or parse tree corresponding to leftmost derivation or corresponding to the rightmost derivation. So all of them are the equivalent. Now, if you will think about the ambiguous grammar, then there is a more than one parse tree, you can say. Either they are leftmost generated or the rightmost generated. There is no need to specify if there is more than one leftmost derivation tree or there is more than one rightmost derivation tree. You can simply say there is more than one parse tree for the corresponding string of a language. Any specific string will contain more than one parse tree, then you can say that is a ambiguous grammar, right? So here I have classified the grammar into the two types. First one is the ambiguous grammar, another one is the unambiguous grammar. Ambiguous grammar tells you you will generate more than one parse tree, or you can simply say there is more than one LMD or RMD possible, right? Similarly, here you can say in case of unambiguous grammar, there is a unique parse tree, right? Or unique LMD and RMD, right? So now I will explain it by the example. The example is given here. Let's the particular grammar, think of particular grammar, E tends to ID oblique E plus E oblique E multiply E oblique E minus E. We want to generate this particular string, right? ID plus ID multiplied by ID in the previous, according to the previous derivation. So I will choose E drives E plus E. After that, this E get replaced. If we will think of the LMD, leftmost derivation in short is written as LMD, leftmost derivation, right? So you will replace it ID, and now this E get further extended by the E multiply E. Here, this E, because extremely leftmost symbol is this E. Once again, you can see here, this E get replaced by the next ID, right? So in this manner, you will achieve ID plus ID multiplied by ID, right? Same string can be generated by the another type of derivation. You will choose E multiply E. After that, you will enhance it by the E plus E. After that, you will replace this E by the ID. After that, this one. After that, this one. So in this manner, so you can see if you will generate the derivation tree corresponding to both the derivations, you can see this one of one derivations where you will choose the E plus E at the beginning. This is the another derivations where you will choose E multiply E at the beginning. So for the string ID plus ID multiply ID, there is a more than one parse tree. There is more than one parse tree. You can see. Hence, the grammar is ambiguous, right? Hence, the grammar is ambiguous. Clear or not clear? Here you can see the grammar is ambiguous. Let us take the another example here. The productions rule is this one: S tends to AS oblique SA oblique A. So in order to generate the string AA, this is a quite simple trivial example to explain the concept. So you will start from S, right? You will drives AS. After that, you will append A. This is the first derivation, right? Right. Another derivation is S drives SA. After that, you will replace A. So in order to generate string AA, there is more than one parse tree. Clear? There is more than one parse tree. You can see here, first one and second one. So any string, any string W belongs to LG, language generated by the grammar, will contain more than one parse tree, is ambiguous. Or you can say more than one leftmost derivation or more than one rightmost derivation. If you will think in term of derivation, then more than one leftmost means leftmost derivation. Means there is no unique leftmost derivation. More than one leftmost derivation. If you will generate the string by the rightmost derivation, then there must be more than one rightmost derivation. If you will think about the parse tree, then there must be only must be more than one parse tree, not leftmost parse tree, rightmost parse tree, because parse tree pictorial representations are same for leftmost and rightmost, right? Let us take another example. This is an example. Grammar is given here. S tends to A oblique AAB, AB SB, S A tends to AAB oblique BS. Is this particular grammar is ambiguous or not? You can see. If people perform the derivations, so you can see, I will take this particular production in order to generate a string AB, any string, for the any string. If more than one parse tree will be possible, then grammar is ambiguous. You can affirm about that. So for particular string AB, I will try to derive. So I will choose S tends to AB SB, right? And after that, that S get replaced by A, right? So I will start leftmost derivation. If you will think about the leftmost derivation, so it is the AB SB, right? I will choose this. This S is replaced by this one. From the starting symbol, we will begin. After that, leftmost non-terminal will be S. So this S get replaced by AB, and after that, there is a corresponding A. So I will take A and B, right? So I will generate this string AB. Another way is S drives, you can see, AAB. If I will choose this particular production, right? After that, you can see the extremely left symbol is non-terminal is A. So this A get replaced by BS, right? Because this BS. So B, A, B, S, B, right? A, B, S, B. After that, this S get replaced by what? You will require A. So you will replace it by A. So you will get A, B, A, B. If you will think of the derivation tree, so S drives A, B, S, B. After that, this S get replaced by A. This is a first derivation tree for this one. And for this one, S drives A, B. This A is replaced by BS and this S is replaced by A. So more than one parse tree is possible, or you can simply say more than one leftmost derivation is here. If you will think of the rightmost, then more than one rightmost derivation also possible. Then you can say this grammar is ambiguous because there is a more than one parse tree for a string AB. You can see different parse tree will be here. So in simple term, we can say this is a ambiguous grammar. So these are the references to follow. Thank you.